Hello, welcome back to Cardinal Science. In this video, we'll be continuing through our IGCSE Edexcel Chemistry. In this video, we'll be looking at point 1.25, write word equation and balanced chemical equations, including state symbols, for reactions studied in the specification and for unfamiliar reactions where suitable information is provided. Okay, for 1.25, we need to actually understand what word equations and balanced chemical equations are. So to start with, we'll break down what a simple equation would look like. On the left-hand side, you have your reactants. Now, there doesn't have to be two of these. It could be any number of them, but most commonly there'll be two. And then an arrow leading over to the products. And again, there could be one product or there could be many. Some example of these are as below. Sodium plus chlorine produces sodium chloride. Or hydrochloric acid plus calcium gives you calcium chloride and hydrogen. Okay, now to add to our equations, we might add some state symbols. So there are four of these that we could use. We have S for solid, L for liquid, G for gas, and AQ for aqueous. Now aqueous just means that it's dissolved in water, i.e. it's in a solution. So to our example below, we have sodium reacting with chlorine to produce sodium chloride. Now we put the S to indicate that sodium is a solid, G to indicate that chlorine is a gas, and S to indicate that the sodium chloride is also a solid. Now, word equations are a bit clunky and they don't contain as much information as what we might call a symbol equation. So we'll move on to those now. Now what we do with this is we use the symbols from the periodic table to construct the equation. So we take the symbol for sodium and the symbol for chlorine and then we make sodium chloride as below. Now one thing to note here is that Cl2 is chlorine, and that's because chlorine, like hydrogen and a few other elements, are actually diatomic. So in the elemental form, they exist as two atoms bonded together in a molecule. The big two I've put in front of the Na and the two in front of the NaCl are to do with balancing, and that'll be explained on the next slide. Okay, now one of the key fundamental laws of the universe is something called conservation of matter, which means you can't create or destroy matter. Now therefore, any of our equations need to not represent any destruction or creation of matter, and I'll represent this like this. So if we started off with this equation up here, Na plus Cl2 goes to NaCl. We have one atom of Na reacting with two atoms of chlorine, which are in a molecule, to form NaCl, which I'll represent like this for now. It's not quite how it works in reality, but we'll deal with that for now. Okay, now what you might notice is on the right hand side of the arrow there's only one Cl, which would mean that this current equation will be representing the destruction, the random loss of one chlorine atom, and that doesn't work. We can't allow that. Okay, so what we then have to do is balance the equation to make sure that there are the same number of each atom on each side of the equation. So we do the left hand side and the right hand side separately. Now this is where those big 2's come in, because if in fact we reacted two Na atoms, as you can see here, with two chlorines, as we have already in that little molecule that I drew, and then we can create two NaCl molecules. So that big 2 tells us that we have two of these. Now if you count the amount of atoms on each side for each element, you'll see that we have two sodiums on each side, two chlorines on each side, and therefore it is now balanced. Now here I'll show you a nice method that you can use to balance any equation, no matter how complicated it is. Once you get adept at doing this, you won't have to use this anymore. But here's what I would absolutely recommend doing when you are starting out. So here's how you go. We've got this equation up here, C2H4 reacting with oxygen to make carbon dioxide and water. So what we do is we first write down which elements we've got. So we've got carbon, hydrogen and oxygen. Now we're going to write down what we have on each side, and then we're going to adjust it to make it work. So initially we have on the left hand side 2 atoms of carbon, 4 of hydrogen and 2 of oxygen. And on the right hand side we have 1 carbon right there, we have 2 hydrogens, right, 2 in the H2, and then we have 1 oxygen here, 1, and we have 2 oxygens here, so therefore we have 3. Now in this case I would always, especially with equations like this where you're burning hydrocarbons, always balance in this order: carbon, then hydrogen, then oxygen. So we've got 2 carbons on the left and only 1 on the right. So what we could do, I'll do this in blue, is you could stick a big 2 in front of the CO2. Okay, now we've done that. Let's recalculate the right hand side. So now we've got a big 2 there. We now have 2 carbons. Our hydrogens haven't changed because they're on the other water molecule over there, but our oxygens now have changed because we put a big 2 in front of the CO2, which means we now have 4 oxygens from the carbon dioxides and 1 in the water, so that's now 5. Okay, now we're going to need to try to fix the hydrogens. So we have 4 hydrogens on the left and we have 2 on the right. So we're going to need to somehow get 2 extra hydrogens. And we can do that by putting a 2 in front of the H2O. Now that we've made a change, we do the same thing again. We recalculate. Obviously, we need to recalculate for the side that we've made the change on. So we've put a big 2 in front of the H2O. Now, let's go through it again. How many carbons on the right? Well, we've still got 2. How many hydrogens on the right now? We've got 2 times 2 because it's obviously an H2, which means we therefore have 4. So that's fixed our hydrogens. And our oxygens, well, we've now got 2 times the 1 in the water molecule, so that's 2. And we've got 4 from the carbon monoxides, so that's 6. So now if you look, we've got 2 and 2, we've got 4 and 4, so those are okay, but we've got 6 and 2. So now we just need to fix the oxygens on the left. So now what's good about oxygen here, and this is why we did it in this order, is that oxygen is not bonded to anything else on the left hand side here, which means we could put any number in front of that and it won't affect anything else. So we need to turn 2 into 6, so we're going to multiply it by 3, so we put a big 3 in front of that. Now if you want, we can just go through and check that that's alright. So we've made a change on the left, so let's just check with a new column. So how many carbons on the left do we have? We have 2 there. How many hydrogens on the left? 4. And how many oxygens now? Well, we've got 3 multiplied by the 2 because we've got 3 oxygen molecules. That brings us to be 6, and therefore it is now balanced. Okay, here's another example. You might want to pause the video here and have a try on your own. Okay, here we go. We'll write down the elements that we have in order on the left hand side. So we've got zinc, which is Zn, we've got H from our HCl, and we've got Cl. Okay, now how many of each one do we have on the left hand side? We have 1 zinc, we have 1 molecule of HCl, which means we have 1 hydrogen and 1 chlorine. Now on the right hand side we have ZnCl2, so we have 1 zinc atom and 2 chlorine atoms and 2 hydrogens in the H2. Now let's see if we can fix the hydrogens first. So we've only got 1 on the left and we've got 2 on the right, which means we need to multiply the HCl molecule by some number to give us 2. That's obviously going to be 2. Okay, so now we've made that change. Draw a line and we'll recalculate for the left. So we haven't touched the zinc, so we've still got 1 of those. We've now got 2 hydrogens and we've now got 2 chlorines, which means this is now fixed. Excellent. Okay, here are 3 examples that I think you should have a go at. The real thing with balancing equations is just practice. The more you do, the easier it will become, and you'll be able to do it by eye as opposed to filling out the table as I've shown you. Pause the video, have a try at these, and I'm going to work through these in the coming slides. Okay, number 1. Let's write down which elements we have. We have magnesium, we have oxygen, we have hydrogen, and we have chlorine. On the left hand side, how many magnesium do we have? Just 1. How many oxygen? Just 1. We also have 1 hydrogen and 1 chlorine. On the right hand side, we have 1 magnesium, we have 1 oxygen, we have 2 hydrogens, and we have 2 chlorines. So there are 2 things we might want to fix here. We need to fix our hydrogens and we need to fix our HCl. Now that's quite convenient because on the left hand side the hydrogen and the chlorine are bonded together in the HCl molecule. So we're going to try to fix both of those at once by multiplying that whole molecule by some number. What number is that likely to be? Well, since we've got 1 and we want 2, we're going to multiply that by 2. Now let's just double check that that's worked. So we put a 2 in front of the HCl. We haven't touched the magnesium, so that's still 1. We haven't touched the oxygen, that's still 1 as well. But now the hydrogen is multiplied by 2, so we have 2. And 2 times 1 for the Cl also brings us 2. That's now balanced. Okay, this one's a little bit more complicated, but we're going to follow the same steps and we'll get through it. So we'll first write down which elements we have: calcium, oxygen, hydrogen, and sulfur. Now, how many calcium do we have on the left? We have just one. How many oxygen on the left? Now, obviously, there's oxygen in both molecules, so let's be careful here. We have 2 in the calcium hydroxide, since everything inside the bracket is multiplied by that 2 outside of it. Okay, so there's 2 there, and there's 4 in the sulfuric acid, which means we have 6 oxygens. Now, how many hydrogens do we have? We have 2 in the calcium hydroxide and 2 in the sulfuric acid, so that's 4. How many sulfur do we have? Just 1. Okay, on the right hand side, what do we have? We have 1 calcium, we have 1 sulfur, we have 5 oxygens, because there's 4 in the calcium sulfate and 1 in the water, and hydrogen wise we only have 2. So what shall we try to fix first? Okay, let's try to fix the hydrogen. We have 4 hydrogens on the left and 2 on the right, and we can only have hydrogens in the water molecules on the right hand side, so we can put a big 2 in front of the water there. Okay, now we've done that, let's see how that's affected things. So on the right hand side, the calcium will stay the same because we haven't affected that. The oxygens will have changed, and so will the hydrogens, but not the sulfur. That will still be 1. So let's do the oxygens first. We've got 4 in the calcium sulfate, as we had before, but we now have 2 times the water molecule, which therefore means we have 2 oxygens in there. That gives us a total of 6 oxygens on the right hand side. And hydrogens, we now have 2 times 2, which is 4. So 1, 6, 4, 1, 1, 6, 4, 1, it's now balanced. Okay, here's another combustion reaction. This one's quite special, and you'll see why in a moment. So let's do it the normal way. Elements down the left, carbon, hydrogen, and oxygen. What do we have on the left hand side? 2 carbons, 6 hydrogens, 2 oxygens. What do we have on the right hand side? 1 carbon, 2 hydrogens, and 3 oxygens. Note there's 1 oxygen in there and 2 in there. We'll fix the carbons first. So we need to have 2 carbons on the right, but we only currently have 1, so we're going to multiply it by 2. We'll write a new column. We've now got 2 carbons, but we've got more oxygens now, haven't we? So we've got 2 times 2 plus 1, which is 5 oxygens now, and the same number of hydrogens, which is 2. Now we'll fix the hydrogen. We've got 6 on the left and 2 on the right. So we're going to need to multiply our water molecule by 3 to bring that number of hydrogens up to 6. Let's write a new column and see what we have. We still have 2 carbons. We now have 4 oxygens from the carbon dioxide molecules, and we have 3 from the water, which means we have 7 oxygens. We have 3 times 2, which is 6 hydrogens. Okay, now you can see we've balanced both the carbons and the hydrogens. We just need to fix the oxygen now. So we need to go from having 2 oxygens to having 7 oxygens. What can we multiply 2 by to get 7? Well, it's not going to be a whole number, but that's absolutely fine. Now what you would do is you would write 3.5. That's absolutely fine to have a 3.5 in there. So now we have, on our left hand side, 2 carbons, 6 hydrogens, and 3.5 times 2, which is 7 oxygens. That's now balanced. Now, how is this examined? Well, balancing equations and equations in general are a basic skill that can apply to any topic in chemistry. So they tend to come up as part of other questions. You do from time to time get individual balancing equations questions that you'll have to solve, but more often than not, they'll be part of a different question. It's a skill that you need to really make sure that you're very strong at, because it will underpin a lot of other chemistry. Thank you for watching. I hope it's been helpful. Please leave a like and subscribe, or a comment below if you have any suggestions as to what can be covered in future videos. Thanks again.